are the Group 1 in CS 107, and we are here to discuss the FSM or Finite State Machine. We have DFA and NFA. Uh, DFA stands for Deterministic Finite Automation and Non-Deterministic Finite Automation. And also, our Java program to discuss with you everyone. Now, let's first discuss the DFA or Deterministic Finite Automata. Deterministic finite automata are finite state machines that are accepts or reject strings of characters by parsing them through a sequence that is uniquely determined by each string. The term deterministic refers to the fact that each string and thus each state sequence is unique. The DFA in short is it accepts or reject the string's characters. Now, the next one is NFA or non-deterministic finite automation. It's a theoretical concept in computer science and automata theory. It's a mathematical model used to describe how machines can recognize patterns using string characters. And the summary of this for explanation is it's not need to obey restriction for any transitions. That's all. And for the next example now is,
And now we're going to proceed to the example of DFA or the deterministic finite automation. This diagram has three states that I'm going to call A, B, and A. While A and B are lowercase, the states are usually represented on OR nodes in a graph. The initial state is not explicitly specified, but based on the context, I assume it's A, the first state listed. From state A on input B, transition to state B. From state B on input A, the transition to state A. From state A on input A, transition to state A. So the accepting state is not explicitly specified, or based on the context, I'll assume it's A, the last state listed. Also, I'm gonna give an example of NFA also known as the non-deterministic finite automation. Also, the NFA has three states like DFA. The NFA has three states, AB and AB. The AB are uppercase, while the other AB is lowercase. The states are usually represented as oracles or nodes in a graph. The initial state is not explicitly specified, but based on the context, I'll assume this is A, and the transitions are defined by the strings BA, AB, and BB. These strings represent the input symbols and the next states to the transition in a NFA. There can be multiple possible reasons next states for a given input symbol. Here's the possible interpretation of the transitions. From state A to B, and from state B on input A, transition to state A. From state A on input A, stays in A. From state B on input B, stay in input B.
We will proceed to our Java program executed by Eclipse. As you can see, we already made a Java program called DFA and NFA Java. Now we will run our program and see what will be. As you can see here, it is a user-defined program. Now will enter the number of state 3, which stands for Q0, Q1, and Q2. Now enter the transition states 0 and 1 and enter the transition table of state 0. Let's try 0, 1. For state 1 is 1, 2, and state 2 is 2 and 0. Now this will be the Q0, Q1, and Q2. And enter the input string. Let's try 0, and this will be the table. As you can see here, let's analyze this table. The transitions table, state 0, if we input 0, the next step will be Q0. And if we input 1, the next step will be Q1. In state 1, if we input 0, we will go to Q1. And if we input 1, it will input the Q2. Now in state 2, if we input the 0, here we will see that it will go to Q2. And if we input the 1, in state 2, it will go to Q0. So it will not be accepted as string. You can see here, the string is not accepted because our initial state is Q0, and if we type 0, it will go to Q0 also. As you can see here in state 2, we have the Q2, and if we type 1 in our table, it will go to Q0. Now we will proceed to our NFA Java program. As you can see here, we already have a program here. We already did some typings. Now we will just have to run it. As you can see here, enter state, so comma separated, so we will input the Q0, Q1, Q2. Now enter alphabet 0, 1 for our loopings, and enter initial state. So this will be the initial state of our NFA. So let's type Q0 for our initial state, and final state, which is the Q2. Now we enter the transition to our NFA. So let's try Q0, input 0, go to Q0. Q0, input 1, go to Q1. Now Q1, input 0, go to Q2. Q2, input 1, no, Q1, input 1, go to Q2. Now Q2, input 0, go to Q2. Now Q2, input 1, go to Q2. Now as you can see here, we already did some of this will be the transition table. Now we will enter the string to determine if it's acceptable or not acceptable. So let's put the string 1, 1, 0, 1. As you can see here, it's inaccept true because 1 in Q0 and if he input 0, it will go to Q0, while if the Q0 inputs the 1, it will go to Q1. Now if the Q1 inputs 1, as you can see here, Q1 inputs 1, go to Q2. Now 0, Q2 input 0, it will go to Q2. Now if he inputs 1, as you can see here, Q2 inputs 1, it will go to the end state, which is our Q2. So it accepts true.
Thank you for watching our video presentation of FSM Without Output featuring DFA and NFA Automata.